Alright, what's up guys? Another day, another Leetcode. We're going to do binary tree in order traversal. So, in order means pretty much traverse the left, traverse the middle, traverse the right. So go from left to right. Let's see what's going on here. 1, 3, 2. So it's like 1, there's nothing on the left, middle, that's why 1's the first. And traverse the right subtree. So left is first is 3, and backwards is 2. Okay. Boom, 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 boom. Let's take a look at what we got here. What are the constraints saying? Number of nodes in the tree, 0 to 100. Okay. No values less than 100 to 100. Okay, no one cares. Recursive solution is trivial. Could you do it iteratively? I could, but I'm not going to right now because I don't fucking have the time. It's 4:13 a.m. Don't ask me why I'm doing this shit. I just love coding. Alright, so base case. Okay, so here we're gonna have 0 nodes, so store is empty array, return store. So that way if it's 0, return 0. I want to also have memory. I need to remember what items I've traversed. So let's do def in order recursive in order. Let's just call it that. I don't know what else to call it. It's going to take a node. It's going to take an array. So we're going to pass it in stores. So that way when we recurse, we can just feed whatever the output is back to store and then just return it out here. So if node dot left, so if node dot left, then node equals node dot left. Or no, if node dot left, I call it on itself. So recursive in order node dot left arr. So if it's 1 and so if it's 2 and there's no dot left, I call it on 3. So 3 is the root node. So basically you're making the root node whatever the call is. So 1 is the root node, nothing on the left. Is something on the right? Yes. Then now 2 is the root node, something on the left? Yes. So now 3 is the root node. And then you keep going until you hit 0 at 3, and then you go backwards. So in this case, you start at 0. The first element's 1 because there's nothing on the left, so back, boom. Then you go 2, something on the left, yes, boom. So 3, something on the left, no. So you go back to 3, then you go back to 2. So I'm going to do that here. If array dot append node dot val. So whatever the current node is after it traverses the left side, because now you're going to the root node, so it's left, root, right. Well, whatever you traverse on the left, it means that node next is the root node. If node dot right recursive in order then call recursive in order what is the node? So it's going to be root is the node I'm feeding it. So that's your base node, and then the array is store. If node dot left. Oh, we need a base case. Because what if there is no node dot left? Then you're not going to recurse anything. So if node. So if the node's null, then just return. If the node is none, there's no null in Python. There we go. Because let's say you get all the way to the end node at 3, right? 3 is your end node. If node is equal to none after, then you just return. You come back, and that's what tells you to either go node left or right. So if left, traverse left. Actually, you could probably even get rid of that if statement on the right side, because you only need to check if it's on the left first, because you want to go left first. So if it's on left, go, and then if you get to the right and you finally make it to none, you return back. So let's try submitting it. Let's go. 74% defeated. So that's pretty much it. What it's doing there is you're going left. When you can't traverse left anymore, then you go back to the middle node relative to what was left. So if you're at the root node, there's nothing left, you go back to the root node. If you're at the root node and something is left, this is your new root node. Now you're checking left and right again. So once you get that memory in a recursive, you have to pass it back to the original function so it doesn't refresh that array. That's why I passed in the array here. Because if I was to do this recursion within this, it's going to keep resetting and I'll lose the memory for store. That's why I did it in a separate function and then passed it back. So those are some tricks you can use when you're using recursion. So if you like the video, please give it a thumbs up. If you have any comments, feedback, put it in the comments below, and don't forget to subscribe to the channel. I'll be making many more of these, and yeah, it's 4:20 a.m. right now. I just want to do a quick spew out some quick knowledge saying that, hey, this is what it takes. This is what it takes to get from A to B. This is what it takes to be at the top if you're trying to get there. 1% every day. Doesn't matter how fucking tired you are. Do another question. Do another problem. At least do one a day. And try to push yourself. I'm trying to talk slowly in this like ASMR voice because like obviously people are sleeping. But the point still stands true. You want to be in a position where you're always ready for what's going to come at you, right? So you can only get there by consistently applying yourself every day. So with that, I'm going to head out. Peace.